dy upon dt. What is that? Dy upon dt from second one. It is b into cos t. Try to understand. B into cos t here. Okay. Therefore, ds upon dt is equal to square root of df upon dt whole square plus dy upon dt whole square. That is there. Okay. If I take 0 to a, okay, no problem. This is there. Now ds upon dt is this value. This is square root of ds upon dt is minus a sin t. It will be a square into sin square t plus this is d by dt. This is b square into cos square t. Now if I put cos square t as 1 minus sin square t, yeah, or b value is a square into 1 minus e square. That can be substituted. Let me put that value b, because we have to find out in form of eccentricity. Substituting this value, we will get here. Okay, this 2 pi is this value. So finally we get what is ds upon dt. Ds upon dt is equal to a square into sin square t plus b square is this. This is a square into 1 minus e square into cos square t into cos square t. First is this. It is nothing but a square into sin square t plus second is this value. This is a square into cos square t minus e square into cos square t. Sorry, a square is also there. Minus a square into e square into cos square t. Now this is a square only. We can write it as a square, because sin square t plus cos square t is 1, minus a square into e square into cos square t. Is cos square coming? Not coming, no problem. Now here, if I put a square out, it will be a under root 1 minus e square into cos square t. Okay, that is the value of this ds upon dt. Now here it is x, so let me substitute this value here. So therefore the formula of area, now therefore area will be given by this formula. Therefore required area of the solid generated of surface of the solid generated will be this value. This is 4 pi. I have taken 0 to pi by 2. X here, x is this value a cos t. Let me write a into cos t under the square root value. Okay, this is 1 minus a. I have to take out. This is a square here. If you have cos t under the square root is 1 minus e square. This I have to write as 1 minus sin square t. Cos square t is 1 minus sin square t here. Try to understand why I have to substitute this. That I just wrote down. This is dt. ds upon dt is this value. Okay, now let me further resolve it. Therefore, this value is giving us 4 pi a square. This 4 pi, okay, that is twice, okay, no problem. 4 pi a square here, this a square is taken out, 0 to pi by 2, it is cos t under the square root value. What is this whole value? This is 1 minus e square, let me take. This is plus e square into sin square t. Try to understand, this is minus plus 1 minus e square is taken out, and this e square into sin square t into dt. Dt is out. Okay, now what we will substitute here? Let me put further putting e sin t. Let me take equal to u. Let me take u. Third variable, third parameter I mean. Therefore, e into cos t into dt equal to du. It is du here. You got the point? E cos t, differentiating it with respect to u, differentiating it with respect to u. So we get this e cos t sin t is cos t into dt equal to du, or dt upon du equal to 1. Du take to that side. It is e cos t. Therefore, cos t dt is cos t dt. Therefore, cos t into dt is equal to du upon e. What are the limits here? Let me put the limits here. This is sin t. If t is pi by 2, then u is e. So at t is equal to pi by 2, u is equal to e. Because sin pi by 2 here, sorry, this one, e into sin pi by 2. Sin pi by 2 is 1. 1 into e is e. U is equal to e. And at t is equal to 0, sin 0 is 0, so u is equal to 0. U is equal to 0. Okay, so limits finally are 4 pi a square. Now this is now 0 to e. Limit 0 to e. Alright. 0 to e here. Now this is finally substitute. This is 1 minus under root 1 minus e square as it is, plus this is e square sin t is u appearing, that is u square into du upon e. E I have to take outside. This e will come out. Let me take here e upon e. 4 pi a square upon e. So this formula, this a square, if I write it as under root of this and whole square, no change. So that is a square here. This is square root of and whole square. So it is a square plus u square. What is that? This can be now written down as, what is the formula for this? So formula integration of this is, let me write. So area required, or required area, is equal to, required area or area required is equal to, this is 4 into pi into a square upon e. E eccentricity. Now this is in form of a square plus u square. It will give us, limit we will apply finally 0 to e. But this is what? First comes out to be 1 upon 2u under root, the same value, complete. This is nothing but 1 minus e square plus u square. Okay, then plus 1.2 into this a square. A square is nothing but 1 minus e square only, into log of, let me write here, into log of this value is same value completely, but first will be this u, this is u here, u plus, it will be u plus under root, the same value, 1 minus e square plus u square. And limits now, okay, let me write this curly bracket, and this is curly bracket first, then whole bracket is 0 to e limit now. Now we have to substitute e first, then 0. What are the values here? So it will give us, finally we have to substitute the limit. This is the integration. This integration we know about, that if there is a square plus u square under the square root, then it is 1.2 x here, coefficient is, sorry, variable is x, if it is 1.2x under root a square plus x square plus 1.2 a square log of, sorry, x plus under root a square plus x square, same value. So this is the whole value. Now substitute the limits 0 to e. First e upper limit is 4 pi a square, 4 pi a square upon e. In bracket it is 1.2 e, because in place of u we have to substitute e here. Here it is u, that means e square. What it will be? E square and this minus e square cancel out. Only 1, it is 1 only. Plus, let me write this. This is 1.2 into 1 minus e square as it is. Under the log, it will be under the log, it will be e here in place of u. Let me write here curly bracket. It is e here in place of u, and if I put here, this is 1 only. It is only log of e plus 1. So this e square cancel out, so this is 1 only. E plus 1, this is first point. Okay. Minus sign, if I put lower limit, let me put lower limit 0. In place of u, if I put 0, it is 0, complete 0. And minus sign 1.2 into 1 minus e square as it is into log of, what about this value? U 0, 0. Under the square root, it will be this value u 0, but 1 minus e square will come out. It will be 1 minus e square only. So square root of 1 minus e square. That is the value. Log of under root 1 minus 1.2 will come before. This is power 1.2 if it is multiplied. Minus sign. So this upon this will be there. Okay. Let me now first solve it. This is power half power will come before. This is 1.4 then. Or this is whole power half under the square root here. Here, so it's 0, 0. It is under root 1 minus e square. That is 1.2 power will come before. But before that, let me just solve it. What was the value then? This is log, the same value is okay common. Log n minus log n is this upon this. That let me first solve. Okay, so that will be under root 1 minus e square. What the answer here? Okay, log 1 plus e upon 1 minus e, it is coming. Okay, so it is 1 minus e is coming by this 1 plus e upon 1 minus e. But this 1.2, if I put then 1 minus e and 1 plus e cancel out, 1 minus e is in the denominator. That value will be there. But this log 1 plus e, okay, this e is also there. Okay, let me just check that what is coming. 1.2 e. 1.2 e again has come. That means, okay, e if I multiply inside, so it will be 1.2 and 1. 1.22 I have taken outside from both. 1.2, 1.2, that is out. Okay, then divide by e, it will be upon e here, twice e. Yeah, this is twice e. For this 1.2, it means 1.2 has come out. It means first 1.2 is not clear. This is e here. If I put e square cancel out, so only e plus 1. So this e square was cancelled out, minus e plus is 1 here. So e plus 1, that was the first question. Okay, and then minus and this. So, okay, so this is coming as 1.2. If I take out, it will be 4 means 2 pi into a square. E if I take inside, it will be then now 1.2 cancel out, it is 1 only. Plus this 1.2 I have taken outside. 1 minus e square. It is 1 minus e square upon 1 more 2. If I take 1.2, then it will be square root of this value. Because if I take 1.2 here and make a square, This is twice e. This e which I am multiplying this by e. It will be 1.2 e. It means 1.4. If I make it 1.2 square root of this and multiplied by 2. I'm sorry, this is then square here. It will be then square. Okay, I've got the point. So this is, if I multiply this by 4 and make it square this, okay, let me write here square, and this is 1.4. No change because 2 will come out. 2 upon 4 is this. And this is also 4 because the square root is come out. This is 1.4 here. And this is square root is now out. Now it is okay. This is e plus 1 whole square upon 1 minus e square. Now it's okay. Alright. This 1.4, 1.2 I have taken, so this 1.2 will be left over. Then this is log 1 plus e whole square upon 1 minus e square only in the denominator. So 1 minus e and 1 plus e cancel out to 1 plus e. Okay, so that is the point. Therefore, this is equal to twice pi e square. It is 1 plus 1 minus e square upon twice e. Got the point? It's log. Now 1 plus e, 1 is left. Here it is 1 minus a square minus b square. That means a minus b plus b. 1a plus b means 1 plus e cancel out. 1 minus e only left over. So this is the final value. We have to prove this. 2 pi a square. This is 2 pi a square. Alright. In bracket is 1 plus 1 minus e square upon twice e log 1 plus e upon 1 minus e. 100% true. This is the question here. Hence proved. Same answer is obtained. This is the question number 4. Question number 4 we have done. Okay. Now what about the 5th question? This is question number 4. We have completed. Just we squared it and divide by 2. No change because 2 will come before this 2 upon 4, 1.2, that was 1.2 here. Then we can take log n minus log n. Log n minus log n is log m upon n. Is log m upon n. N is 1 minus e square. M is e plus 1 whole square or 1 plus e whole square. This upon this is there. 1.4 we took. 1.2 I have taken outside, so this is 1.2 only left over. Now it is okay. So clearly, same answer is obtained. Okay, this is question number 4. Now let us talk about question number 5. What does question number 5 say? Let me check. Okay, now question number 5 is of what kind? Let me now check it. Question number 5 is, it says, find the surface of the solid formed by the revolution about x-axis of the loop of the curve. This, okay, that is the curve here. So this loop of the curve, from this we can get limits. Okay, the question number 5 here, x, the curve is here, x equal to t square and y equal to t minus 1.3 into t cube. This is the value here. We have solved it. Okay, we just get it. What the loop? What kind of loop is there? If I convert this into Cartesian form, we can get easily what is the form of the loop. Okay, but before that, I'll just find out by parametric form. There's no need of tracing the curve. If there is a tracing of the curve, we can convert this into Cartesian form. So what is that Cartesian form? If I square this and take t common from this equation, it will come out, or okay, 1.3 if I take common, let me make by square here because we want t square, so then squaring it. By square equal to, if I take t common from this, is t 1 minus 1.3 into t square. Okay, so this will give us 3 LCM here. So if I take 3 out, this is t upon 3, it will be 3 minus t square. Okay, now squaring it. It is value of by here. I'm just converting this into Cartesian form so that the curve can be traced easily. Okay, this we did in the curve tracing. That's why I'm doing this. This is now, if I take y square equal to, here it is y square equal to, or 3 into, this is 9 here now, this is t square upon 9, and this is 3 minus t square whole square. What is this? Now this t square, y is 9 into y square equal to t square into 3 minus t square whole power 2. Now t square is x, substituting x here. Therefore 9y square is equal to x into 3 minus x whole square. Now this is the curve. We can trace that if I put x equal to 3, this is 0 here. Okay, and if I put x negative value, x less than, okay, for negative values x is not line, or x is beyond x negative value from origin, the value is not going. But before this value, this is 3 minus x square. Okay, so y square is negative for x negative values. But if I put y 0, then x equal to 3 and x equal to 0. The curve is passing through 0 here. Okay, so this is the, if I take this curve like this, okay, so, or we can take in this way, this is the curve here, but this curve is here x equal to 3, here x equal to 0, 0 to 3 limits we can take in this case. But in this case, this is the curve tracing of that kind. But here t will be what? We have to take t. This is the loop of this. Okay, so in this case, what is talking about is find the surface of the solid formed by the revolution about the x-axis of the loop of the curve. So about x-axis, we have to change this to what are the limits here. That limit we have to find out. Here it is 3, x equal to 3. So if I put here t square equal to 3, that means t equal to plus minus 3. So t is under root 3. And here t equal to 0. When x is 0, t is also 0. So 0 to under root 3. You can just find out this is the loop type. Okay, the loop of this curve here. Find out the area of this loop about the x-axis. This is x-axis here. This is x dash, this is y, and y dash axis. This kind of loop will be obtained simply by this tracing of this curve. Okay, for y square is negative, if x is negative, beyond this curve is not line. So about this x equal to t, 3 x equal to 3 here, and for x equal to 3 it is 0. The curve comes out to be 0 here. Or if I write in this way, this is 0 here, this is the curve. Beyond this x equal to 0, the curve will not lie, and this is the curve here. This kind of loop will be obtained. So here x equal to, okay, 3, the curve is meeting at the x. This is 0 here, then y 0, and this y 0, x is 3 but y is 0. This 3 and 0, the point is. And here x is beyond x, negative value we cannot take, because if I take minus 2, minus 3, or minus 1 even in place of x, then it will be negative. Y will be negative in that situation. We cannot take here negative values. Okay, here we can take x equal to 2, 3, etc. positive, but negative value we cannot take because x is negative here. Y will be negative. So beyond this, the limit, the curve is not existing, doesn't exist. This is the loop here. Now limits, what are the limits? 0 to root 3. Why? Or that can be calculated from there. So this is the form of geometric curve here. So this kind of loop will be obtained. Now point is, what is the area of this curve? So for that, put y equal to 0. From here also we can find what is the value of limits of t. At y equal to 0, limits of t are from this. T can be taken common. This is 1 minus 1.3 into t square equal to 0. So t equal to 0 and t equal to root 3 here. So t square equal to 3 or t equal to root 3 plus minus root 3. And plus root 3 we will take. What is the area of the sphere? For area of the, let me find the solution. Solution of question number 5 we are solving. Area of the surface of the solid generated by revolution of the loop of the curve about x-axis. Here it is about the x-axis here. X-axis here about x-axis. X-axis is the axis of the curve here. Loop, that is the x here. So limit 0 to 3. We can write it as twice pi 0 to root 3. Now it is about x-axis, which is y into ds. Okay, so we have to find out what is 2 pi 0 to root 3. This is y into ds upon dt into dt. All these values are to be substituted in terms of t. Y is there. Okay, but what is ds upon dt? Let me calculate that. Now differentiating first and second, this is first and this is second here. So differentiating first and second with respect to t, we get, what do we get here? So we get here dx dt equal to twice t, and d by dt is equal to 1 minus 3t square upon 3. 3 cancel out. It is 1 minus t square only. 3t square, because this is 3t square. T is 1. 3t cancel out, which is only 1 minus t square. Simply the value of ds upon dt. Now let me substitute these values. Therefore ds upon dt, so this is the formula here. Let me write this formula, and finally ds upon dt. Therefore required area of the surface of the solid generated by revolution of the loop about x-axis. About x-axis is given by this formula. So this is a is equal to twice pi 0 to root 3 limits of t. Variable y is here. This value, this is t minus 1.3 tq, sorry, tq into ds upon dt. ds upon dt is here. Ds upon dt. What did we calculate? No, still we are not calculated that. So this, let me write ds upon dt into dt. Let me calculate now ds upon dt. So ds upon dt is equal to square root of dx upon dt whole square plus dy upon dt whole square. That will give us, let me change this marker. Okay, so this value is, let me rub this now. Here the value of dx dt and dy by dt. What are those values? Let me write here. Under root dx upon dt is 2t. This is 2t whole square. D by dt is 1 minus t square. This is 1 minus t square whole square. It will give us 4t square. This is 2t whole square, means 4t square, plus 1 plus t4 minus 2t square. This is 1 minus t whole, 1 minus t square whole square. 1 plus t4. It will be, let me write it now here. Finally, the value of this will be, this will be under root of t4, 1 plus t4, and this is plus 2, this is 1 plus 2t square plus t4. This is nothing but square root of 1 plus t square whole square. 1 plus t square whole square, this is inside. The square root and this cancel out, so this is 1 plus t t square only. Value of ds upon dt is 1 plus t square. Let me substitute that back there. That value is, now let me rub this. This value is 1 plus t square ds upon dt. So therefore ds upon dt, upon substituting here, area will be 2 pi 0 to root 3 into t minus 1.3 t cube into 1 plus t square. This is the value of ds upon dt. 1 plus t square we have just calculated into dt. Let me multiply them and then integrate each term. Therefore area, the required area, is equal to 2 pi 0 to root 3. First multiplying by 1, which is nothing but t minus 1.3 t cube, same by t square it will be t cube, this t square into t is t cube, minus 1.3 t square t is t5 whole, this is dt. We see here t cube and this 1.3 t cube. Okay, these two terms are like terms. 1.3 t cube and this t square into t is t cube. Okay, so these two are added up. Let me further write it down as 0 to root 3 limits. T is independent term, so this is t minus. So this is minus 1 plus 3t cube. So 3 times and this minus 1 is 2 upon plus 2 upon 2t cube upon 3. This is the value of these two terms. Okay, t, this is 3t cube minus t cube upon 3 LCM, after taking 3 LCM. Okay, so that is 2t cube upon 3 plus it will be, because plus 3t cube minus 1t cube. Okay, this is plus 3t minus sign, this is 1.3 t5. Now dt integration. Now each term can be integrated easily. Integrating it now, therefore required area, of the solid generated, of surface of the solid generated, of the surface of the solid generated by revolution of the loop. Okay, about x-axis, that is there. So this area is a is equal to, we are calculating here, twice pi, this is. Now integrating each term, these integrators t square upon 2 plus sign